Hey YouTube, it's a couple hours, 5 hours later than it was last time, or when I recorded the last video, and between then I had a good, helpful talk with Chris Schneider, and I talk about my program with him, and I ate dinner, and I did my calculus homework, and I worked on this a little bit. And what I've got now is the engine. If I put it at a search depth of 1, it will always make the move that will yield it the most material in the immediate future. So it sees that it can make a move that will put it up by material in 1, and it instantly makes that move. Black sees that it can make a move that will put it up by 8, because 1 minus 9 is negative 8, which would put it up by 8, but we'll put the material to negative 8. As you'll see over here when it takes, this will be negative 8. Alright, negative scores means black is up, positive scores mean white is up. So when the program is iterating through the tree, it just determines, well, it looks at the current node and says, well, if I'm white, I want it to be higher, and if it's higher, it makes it the current top choice. If it's black, it wants it to be lower. So yeah, so it's going to take any piece that it can, is what this means, which is a pretty miserable way to play chess. But if you teach it to only think about material but look 5 moves into the future, it actually gets really smart, especially if you make the king worth a ridiculously high amount of material. And actually, I was thinking about it. Here's another bug I just discovered. If the rook is taken instead of moved, the king still thinks that it can move over here, except that the rook moved. Maybe I don't fully understand that bug. Anyway, castling has been the bane of my existence. But, so of course it's recommending the take. What was I saying? I was saying something about, yeah, it becomes really smart. Oh, the king. Right, the king's value only has to equal 1 more than the value of all the pieces on the board. Right, so for it to be practically the infinite value. So let's see, in material, when you start, you have 8 pawns, that's 8, plus 4 minor pieces, that's 12. 8 plus 12, you've got 20, plus 2 rooks, 30, plus a queen, 39, plus a king. The king should be worth 40. That way the king is of infinite value in the program's eyes if I make the king worth 40. So that's an interesting thing to note. I don't have to make it 200. Because what we're saying by making the king 40 is that if we lose all of our pieces, but we take their king, we're up. It doesn't matter. So as you can see, we always take a piece, no matter what. And which piece it takes with, if there's 2 possible takes, of course it'll make the move that yields most material, but if they're equal in material, it's a completely random process, which I'm so excited about. The moves are not, they're stored in a hash set, which is a random storage system. It doesn't maintain the order that you put the objects in, which means every time I run this program, it's yielding completely different results. See, like right now, black can't make a take move, so it literally makes a completely random move, which I'm so excited that the engine doesn't do the same thing every time. Anyway, that's search depth. That's the beginnings of the engine. It only thinks about material right now, so future things I would make it consider more than just material, for 1, and 2, I will actually get it to work at a search depth of 3. My biggest problem right now is not programming implementation, it's the math behind it. I don't know which branch of the tree to choose, because I just don't know what the algorithm is for what the best move is. So that's where I am right now. This is actually pretty funny. If I put it at 3, it's gonna recommend a move that's at that search depth, because I haven't fixed it yet. It's kind of set for with 1. So it's gonna recommend a move that isn't possible at this point in time. Watch. It's gonna take a while to think because it's at 3. See, it's recommending from here to here. So I guess some point in its future a white bishop got here, or I don't have a light square bishop is black, maybe. I don't know. It's funny because it recommends moves that aren't possible yet. Anyway, oh, that was cool because I moved the printout. So this is pretty neat. Watch this. I'm gonna make the move. Actually, these moves aren't possible yet. I'm going to make a move, and it's not going to update for a while. And during that time, it's building the tree. So you get to learn how much time is spent building the tree and how much time is spent iterating through it. Ready? Building it. Now we're iterating through it. Iterating obviously takes more time, but all right, that's it. See you next time.